This is 4.1, the start of trigonometry. So this is 4.1. So the first thing I want you to do is on your yellow pages, I want you to put your trig function. So if we have a right triangle with an angle theta, across from the theta, this is your opposite side. Next to your theta is your adjacent side, and across from the 90-degree angle is your hypotenuse. And so if you remember from geometry, you started off with three big basic trig functions, which was your sine, which was your opposite side over your hypotenuse, cosine of theta was your adjacent over your hypotenuse, and tangent of theta was your opposite over your adjacent. There are also three what we call reciprocal functions. They're not inverse functions, you need to be careful. They're called reciprocal functions. And so the reciprocal of sine is cosecant. That's your hypotenuse over your opposite. And then the reciprocal of cosine is secant, which is your hypotenuse over your adjacent. And the reciprocal of tangent is cotangent, and that's adjacent over your opposite. Those are your 6 basic trig functions. I want you to put those, if you haven't already done so, on your yellow pages. Okay. We also are going to look at some other properties as well. So if my sine of theta is my opposite over hypotenuse, then that means if I multiply both sides by hypotenuse, that's going to give me my hypotenuse times sine is my opposite, because those will cancel. If my cosine is my adjacent over my hypotenuse, and I multiply both sides by the hypotenuse, that's going to give me my hypotenuse times my cosine is my adjacent, and that will allow me, so therefore your tangent, which was your opposite over your adjacent. So here's my opposite. Oops, let me make it an arrow. My opposite and my adjacent, I'm going to put these two expressions over the other. My opposite is equal to my hypotenuse times my sine, and my adjacent is my hypotenuse times my cosine. So if you notice, we have a hypotenuse in the numerator and the denominator. They will cancel. So we're going to get that tangent of theta equals my sine over my cosine. So we're going to do that on the next screen because I'm going to run out of space on here. So this will also need to go on your yellow pages. Your tangent of theta is equal to your sine of theta over cosine theta, which means your cotangent of theta equals your cosine theta over sine theta. And I want these to go on your yellow pages. So make sure that if you haven't put these on your yellow pages, that you put those on your yellow pages. Now let's go ahead and do some examples. So my example 1, I have a right triangle and a theta, and my sides are 15 and 8. And I want to find my sine ratio, my cosine ratio, my tangent ratio, and then I'm going to find my cosecant ratio, my secant ratio, and my cotangent ratio. So in order to do that, I'm going to need to find this side right here. So to do that, I'm going to have to do Pythagorean theorem. So if I do Pythagorean theorem, let me do this in pink. So my a squared plus my b squared equals my c squared. 15 squared plus 8 squared equals c squared. And if you remember from geometry, these are some triples. So my c squared is going to equal, hold on, let me do the calculator. 15 times 15 is 225. So 225 plus 64, which c squared is 289. And when you square 289, you get 17. This is one of the triples, and we'll talk about the triples on a next screen. And my suggestion would be is to memorize these because these are going to show up a lot. So now we just have to do our ratio. So first off, let's identify everything. So for my 15, my 8 is my opposite side, my 15 is my adjacent side, my 17 is my hypotenuse. And so everything is in relationship to theta. So my sine is opposite over hypotenuse. And if you remember the little trick from geometry, you're going to remember SOHCAHTOA, which means sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's what SOHCAHTOA means. So my sine is going to be my opposite side over my hypotenuse, which means my cosecant is the reciprocal. That'll be 17 over 8. My cosine is my adjacent over my hypotenuse. Secant will be 17 over 15. You flip it. Tangent is opposite over adjacent. That means cotangent is opposite over adjacent. You just flip it upside down. So we talked about triples on the last screen. So just in case you don't remember your triples from geometry, these are the most common ones. I would memorize them because they're going to show up a lot. 3, 4, 5, 7, 24, 25, 8, 15, 17, 5, 12, 13, and 9, 40, 41. So I would write those down and be familiar with them because those are going to show up most often when we do our problems. Okay, example 2. Again, we have a triangle, theta. My hypotenuse is 3, my opposite is 1. So again, this is my opposite side, 3 is my hypotenuse, and this missing one is adjacent. So if I do Pythagorean theorem, and I do a squared plus 1 squared equals 3 squared, that's going to give me a squared plus 1 equals 9. A squared equals 8. A equals square root of 8. And I don't need to do plus or minus because we're talking about side lengths. This is 2 root 2. And now we're going to find everything again. We're going to find sine of theta, cosine of theta, tangent of theta, and then we're going to find all the reciprocals, which are going to be cosecant of theta, secant of theta. Ooh, I don't need that much. Secant of theta and cotangent of theta. Okay, so my sine is my opposite. Oops, I gotta do Pythagorean theorem first. So let me erase that and do it again. Oh, no, I did it. Never mind. Sorry, I'm losing my mind. This is 2 root 2. So my sine is going to be my opposite over my hypotenuse. That means cosecant is 3. My cosine is going to be my adjacent over my hypotenuse. Now when I flip 3 over 2 root 2, you're going to have to get rid of the square root of 2 in your denominator. So you got to multiply by square root of 2, which gives you 3 root 2 over square root of 2 times square root of 2 is 2. 2 times 2 is 4. So this is going to give me 3 root 2 over 4. And then tangent is my opposite over my adjacent. So let me pick a different color. Let's do, okay. So if I do my opposite over my adjacent, sorry, I'm trying to squeeze this in here, multiply by root 2 over root 2, you're going to get root 2 over 4. So it gives me root 2, square root of 2 over 4. When I flip it, instead of trying to flip the square root of 2 over 4, flip the original one, which when I flip 1 over 2 root 2, it's just going to give me 2 times square root of 2. And that is my cotangent. Okay, next problem are starting to find some missing sides and things like that. So example 3, again, I have a triangle, x, 7, this is 35 degrees. So to my 7, that is my hypotenuse. The 7 is my adjacent. So since I have adjacent and hypotenuse, that means I have cosine 35 degrees equals my adjacent over my hypotenuse. So if I want to solve for x, I'm going to multiply both sides by 7. And the key thing here is to make sure that you put your cosine in degrees. And when you multiply 7 times cosine of 35 in the calculator, you get about 5.7. So that is the length of the missing side. Example 4. I have 3x 42 degrees. So 3 is my opposite side, x is my hypotenuse, and that opposite over hypotenuse is sine. So sine of 42 degrees is my opposite over my hypotenuse. However, this time your x is in the denominator. So you basically need to switch the sine of 42 and x because you want to get x by itself. So you're multiplying both sides by x, and then you're dividing both sides by sine of 42. So you end up with x equals 3 over sine of 42. Essentially, you just switched the x and the sine of 42. And when you stick that in the calculator, you're going to get x is about 4.5. And again, make sure that your mode is on degree.